The question is whether conduit buried in the crawl space is considered inside the building, requiring a disconnect. The answer is yes, a crawl space is considered part of the building, regardless of accessibility from the main living area. Since the conduit is inside the building, a disconnect is required to meet current electrical codes. The presence of rigid conduit running into the sidewalk slab presents a challenge, making disconnect installation difficult and costly. It is important to prioritize safety by complying with electrical codes. One possible solution is to install a disconnect at the point where the conduit enters the crawl space. This involves excavating the conduit and installing a junction box to house the disconnect. This can be challenging due to the existing concrete and buried conduit. Another option is installing a disconnect at the meter base. While potentially more expensive, this method might be easier to implement. A qualified electrician can assess the specific situation and recommend the best solution. The electrician will consider factors such as the distance of the conduit run, accessibility, and the existing electrical system. NEC, or National Electrical Code, provides the standards for electrical installations. It is important to understand relevant sections of the NEC and adhere to it. A disconnect switch is a safety device used to de-energize an electrical circuit. It is used for safety reasons to prevent electrical shock. If a fault occurs in the home's electrical system, the disconnect switch can be used to quickly de-energize the circuit. The NEC requires a readily accessible disconnect switch near the point of entry of service conductors into a building. This ensures that emergency responders or electrical workers can quickly shut off power to the building in the event of a fire or other emergency. Because the crawl space is considered inside the building, the service conductors entering the crawl space must have a disconnect switch installed. Considerations must include the working space around the disconnect. The NEC specifies minimum working clearances around electrical equipment to ensure that workers have enough space to safely operate and maintain the equipment. It is important to consider the physical layout of the crawl space and ensure there is enough room to safely install and access the disconnect switch. The type of conduit being used is rigid metal conduit. Rigid metal conduit, or RMC, is a heavy-duty type of electrical conduit that is typically made of galvanized steel. It is designed to protect electrical wiring from physical damage and corrosion. RMC is often used in outdoor or underground applications, as well as in areas where there is a risk of impact or abrasion. The existing rigid conduit makes the task harder to complete. Firstly, locate the point where the rigid conduit enters the crawl space. Secondly, carefully excavate around the conduit to expose a sufficient length for working. Thirdly, cut the conduit using appropriate tools, such as a pipe cutter or saw. Fourthly, install a junction box suitable for outdoor or damp locations, ensuring it is properly grounded. Fifthly, terminate the conduit ends within the junction box using appropriate fittings, such as conduit connectors and lock nuts. Sixthly, mount the disconnect switch within the junction box, following the manufacturer's instructions. Seventhly, connect the service conductors to the disconnect switch terminals, ensuring proper polarity and tightening connections securely. Eighthly, install a grounding electrode conductor from the disconnect switch to a suitable grounding point, such as a ground rod or the building's grounding system. Ninthly, test the installation to ensure proper operation of the disconnect switch and verify that all connections are secure. Tenthly, backfill the excavated area, taking care to protect the conduit and junction box from damage. The alternative solution to install a disconnect at the meter base involves several considerations. Firstly, assess the feasibility of installing a disconnect at the meter base. Consider the available space, existing wiring configurations, and local utility requirements. Secondly, coordinate with the local utility company to ensure compliance with their regulations and procedures for installing a disconnect at the meter base. Thirdly, obtain any necessary permits or approvals from the local electrical authority before proceeding with the installation. Fourthly, select a disconnect switch that is suitable for outdoor use and rated for the appropriate voltage and amperage. Fifthly, install the disconnect switch at the meter base, following the manufacturer's instructions and local electrical codes. Sixthly, connect the service conductors from the meter to the disconnect switch, ensuring proper polarity and secure connections. Seventhly, install a grounding electrode conductor from the disconnect switch to a suitable grounding point, such as a ground rod or the building's grounding system. Eighthly, label the disconnect switch clearly to indicate its purpose and the circuits it controls. Ninthly, test the installation to ensure proper operation of the disconnect switch and verify that all connections are secure. Tenthly, notify the local utility company upon completion of the installation to schedule an inspection and ensure compliance with their requirements. The NEC has rules about crawl spaces. Crawl spaces are considered potentially damp or wet locations, so any electrical equipment installed in a crawl space must be suitable for use in such conditions. This means that the equipment must be listed and labeled for use in damp or wet locations, or be protected from moisture by an enclosure. The NEC also requires that all electrical equipment installed in a crawl space be readily accessible for inspection and maintenance. This means that there must be sufficient space around the equipment to allow a qualified electrician to safely access it. There are different types of disconnect switches available. A fuse disconnect switch incorporates fuses to provide overcurrent protection. These are typically used for higher amperage circuits and offer enhanced protection against short circuits and overloads. A non-fuse disconnect switch simply provides a means of disconnecting the circuit without any overcurrent protection. These are suitable for applications where overcurrent protection is provided elsewhere in the circuit. A manual disconnect switch is operated by hand and requires a person to physically switch it on or off. These are commonly used for general-purpose applications. An automatic disconnect switch is designed to automatically disconnect the circuit under certain conditions, such as a power outage or equipment malfunction. These are often used in critical applications where it is important to quickly de-energize the circuit in the event of a problem. It's important to choose the correct size and type of wire. Ensure that the conductors used for the installation are appropriately sized for the load they will be carrying, in accordance with the NEC. Select conductors that are suitable for the environmental conditions, such as moisture and temperature, present in the crawl space. Use appropriate connectors and terminations that are listed for use with the type of conductors being used, and ensure that all connections are made tightly and securely. If the existing panel is being replaced, consider the new panel specifications. Ensure that the new panel is properly sized for the load it will be serving and that it is installed in accordance with NEC and local electrical codes. Verify that the new panel is properly grounded and bonded to the building's grounding system. Ensure that all circuit breakers in the new panel are properly sized and rated for the circuits they will be protecting. Label all circuits in the new panel clearly to indicate their purpose and the areas they serve. Consider surge protection. Install surge protection devices at the panel to protect sensitive electronic equipment from voltage spikes and surges. Surge protection devices can help to prevent damage to appliances, electronics, and other equipment caused by lightning strikes, power surges, or other electrical disturbances. Bonding and grounding systems are critical for safety. Ensure that the grounding electrode system is properly installed and connected to the panel and all metallic components, such as conduit and enclosures. Bond all metallic components together to create a low impedance path for fault currents to flow back to the source. Verify that the grounding and bonding systems comply with the requirements of the NEC and local electrical codes. It's beneficial to conduct a load calculation. Perform a load calculation to determine the total electrical demand of the building and ensure that the service entrance conductors, panel, and other electrical components are adequately sized. Consider both the existing loads and any anticipated future loads when performing the load calculation. Use the results of the load calculation to select the appropriate size and rating for the electrical service equipment. It is recommended that a qualified electrician inspect the crawl space before starting any work to identify any potential hazards or code violations. The electrician can assess the condition of the existing wiring, identify any potential water intrusion issues, and ensure that the crawl space is properly ventilated. The electrician can also provide recommendations for addressing any issues that are identified. Some jurisdictions may require a permit for electrical work, especially panel replacements. Check with the local building department to determine if a permit is required. If a permit is required, be sure to obtain it before starting any work. The building department may also require an inspection of the work after it is completed. It's important to adhere to all applicable codes and regulations. Ensure that all electrical work is performed in accordance with the requirements of the NEC and local electrical codes. The NEC provides comprehensive standards for electrical installations, including wiring methods, grounding, overcurrent protection, and equipment installation. Local electrical codes may have additional requirements that must be followed.